everyone, and welcome to our next webinar, Field Notes on taking AI to the edge, so deploying modern ML models to the browser and edge devices. We are joined today by Alexander. Thank you so much, Alex, for joining us today.
Thank you for having me.
And for those who are getting to know Align AI, really, we're a knowledge management platform that helps companies capture, update, and improve internal standards and best practices around AI. So our goal at Align AI is to make it easier for people to capture their unique knowledge within their company, and then significantly reduce the time it takes to create and publish new data and AI information for their peers. So thanks everyone for joining. This is part of our monthly Field Notes series. Alex, I'd like to throw it to you, if you don't mind, to introduce yourself, the company you work for, and some of the stuff you've been working on lately.
Sure. Thank you very much. So my name is Alex, and I work as an AI engineer in Beehive AI. So in Beehive, we are building a qualitative intelligence platform, which aims to make it easier for companies to talk and to interact with their customers. And we do it through dashboards which combine quantitative and, more importantly, qualitative features of interactions with customers. And we encourage our clients to talk with their clients, with their customers in more open-ended way through open-ended questions, which we are very capable of analyzing.
Wonderful.
And and in my free time, I work on deploying modern deep learning models to the edge.
Yeah, and I think today we're going to set aside some time for you to share one of the side projects you've been working on related to edge deployment too. So really excited to see that.
Yeah, what a casual kind of thing to do on the side there, Alex. That's great.
Yeah, and for folks, also, Reagan, would you mind introducing yourself since you'll be joining the call today as well?
Yeah, for sure. Thanks so much, Nick. I'm Reagan, co-founder and CEO of Align AI, and super excited to have this conversation. This is a topic that I know is extremely relevant in the manufacturing industry for folks that are kind of deploying kind of IoT devices and thinking about how they can take some of this intelligence and implement it more towards the hardware. So I'm super excited to have this discussion, and I'm really excited to see what you have to show today, Alex.
Yeah, leading up to the conversation, Alex, you made the point that I think it's important to open with, where it's not all about these huge models on the cloud. You can really add value in your organization with some smaller models via these edge deployments and browser deployments as well.
Yeah, for sure. Nowadays, a lot of discussions are gravitated towards large models which exist and run in huge data centers in cloud and are accessible only through API, but it is not all deep learning and machine learning which we can get, and sometimes you do not actually need these huge models, and sometimes you even cannot have such models. For example, when you are running some operations in a factory which doesn't have any internet access, for example, or you cannot have access to the internet or to some APIs due to security reasons. It is another important point of all of that. And because of that, you have to figure out and find different ways of using some of the advances. And what I found while working on this project is that you can actually have very good performant models for your specific cases when you can narrow the scope enough, because obviously you cannot have very small model which can do all the things like run like all of your factory using like small or very small model, but you can have very efficient small models running on not so performant hardware, and if you do it right, sort of.
I was just gonna say there's a big trend. I was just at a conference in San Francisco this week, and Andrew Ng was there talking about small data and this kind of new way or perspective to look at data. We've talked about big data for a long time, and now we're kind of getting into more kind of meaningful, curated, smaller data sets that are still very useful, build performant models. So I think this is super timely.
Agree. So starting general for our audience, let's talk about considerations from a design standpoint. So design aspects that people need to think about when they're creating ML models to work in production. I wanted to speak to both of you around what you've seen and what people should consider.
Yeah. So first off, what I saw multiple times when working in both academia and sometimes even in other companies in industry is that in some cases people try to create new models and think that if you have very specific use case, you have to create very specific solution, very specific architecture of neural network or something like that. But in the vast majority of cases, this is not the right approach, because by now we have thousands of different architectures from small to large, and the main thing you need to understand is which one of them works for you and to which one is the one you can start with. So at some point you may need, or if you have very complex case, for example, like we have in Beehive, so we have very like more complex cases and set of scenarios. Because of that, we have to work on our own architectures. But in many cases, for example, in manufacturing industry, you can start small, you can start very lean, and you can take existing model and understand how you can apply it to some problem. So I think the first thing you need to do when starting this process, you need to understand the use case, not architecture, not like select model or create model. You need to understand why do you need, like why first before anything else.
And also physically, maybe you cannot deploy large models. Like there's not enough RAM machinery in terms of the
this is another very good point and another point of consideration, that you need to understand why, and you need to understand your limitations. For example, you might have a very nice use case for applying some of modern like machine learning tools or whatever, but you may not have like even the least computational capacity on the machine itself, or you may not have enough data, because like data is the key for deep learning. So no matter what architecture or whatever, if you have some specific case, you cannot implement it without the data. So if you don't have, or you do not have means to create enough data, you cannot do anything, like whatever amount of computational power you have. So it will not work. So you need to have a lot of thoughts and consider a lot of things even before you start.
We even see in the more advanced teams, the data quality still being an issue that comes up, even with their more advanced large models too. So you make a great point. Start with the data. What do you have available? And then think about the possibilities from there.
Yeah, that's a very important thing. And from that, and one thing that I discovered while working on one of the projects, which I will show a bit later, is that sometimes people underestimate the power of synthetic data. So it might be a case that you, for example, might have very limited amount of data, but it is possible to create a huge training data set for deep learning models from this small amount of data. And but you need to sometimes be very creative about the way how you approach this issue of lack of data. But if you can do it, if you can overcome this issue, it can bring you like great results.
And I think there's another interesting concept in there related to a lot of folks sharing around foundational models. I know, Reagan, you've heard a lot more about the concept of starting with a foundational model instead of building from scratch too, and then building smaller models off of that.
Yeah, we're seeing a lot of trends of just like, especially in manufacturing, being able to look at kind of a diverse set of data. It becomes more performant. But I think what the most interesting thing here is that I'm hearing is like, also understand kind of the specs of where the model is going to be deployed to. Because Because like that's one of the biggest constraints that we're talking about today is really just like, all right, this model has to run in this kind of environment, and what kind of environment are we working with, and how is data getting to and from that environment securely, and how much, CPU, memory, things like that are we working with within that environment? How do we work backwards to decide the technique we're going to use, and what kind of data gets incorporated into that?
Yeah, so in that vein, I think we should introduce the concept of edge or browser deployment to the audience as well too. So we talked about general deployment of models, but what are some unique characteristics or architectural differences to consider when deploying models towards the edge?
Yeah, so deployment of models in browser is one of the cases of edge deployment. So basically, edge deployment is the concept of deploying models essentially where the data is, so where the data is produced. For example, if we're talking about some manufacturing machinery, so we want to deploy these models either on this machine or somewhere like very nearby, because in many cases, machinery can be very specific and very like isolated environment from which you cannot, into which you cannot put much. So they might be like very isolated, and data may be available through some interfaces connected to this machinery. And yeah, so basically you want to deploy your models as close as these sensors or data producers as possible. And why I chose working with models in browser, because this is one of the easiest ways to show edge deployment, because basically everyone has a browser on their computer, even in the phone. So you have access to this edge device, and it is very easy to show people how these models can actually run, and what are like pros and cons of this kind of deployment. So it is just a very nice demonstration case in this sense. Yeah.
Would you mind, because I'm very curious to see kind of the project that you've been working on for browser deployment. And I think it's a great example of how you can show proof of concept in browser deployment to kind of show that proof of concept and show that value before you do a wider deployment of the model too. So if you could, Alex, I believe you have the ability to screen share. Would you mind sharing kind of the project you've been working on?
Yeah. Could you please enable screen sharing for me?
Yep.
Yeah. So here is the website. Obviously, this kind of deployment involves website. And so here there are three main points for deploying models on the edge. It is like security, which we discussed. Latency is also another point that in many cases you want to get the result as fast as possible, and not everywhere good internet connection with very low latency is available. So in many cases it will be more beneficial to deploy something a bit like on a less performant device but closer to the data producing machine than having very, very performant hardware somewhere in the cloud, but with very low bandwidth. So it is another consideration. And cost savings, it is more for sort of providers. So basically, if you have some company which you run and you want to scale, if you deploy as much compute to your clients, you will be able to scale easier and with less costs associated with that. And one case which I wanted to show as close as manufacturing as possible. So this is the case I worked on with researchers from the University of Michigan. And what we tried to do here, we tried to tackle the problem of analysis of electron microscopy. So it is easier to show than explain. So here we have a set of microscope images. So these particles are actually very, very small. So they are about less than 1 micron in size. Yeah. So And because of that, the only way you can analyze them is through these electron microscopes. And the problem is that it is quite hard to analyze them, even using these microscopes. You have to like go to these microscopes, set up all the environment and do actual analysis and like perform a lot of things. And it is very, very time consuming process. So if we were able to automate it and extract some, like all the possible data automatically, it would be really nice. And what we did here, we basically trained very small. As you can see here, the model itself is just 4 megabytes in size. So in terms of modern like neural networks, it is almost nothing. Like just 4 megabytes, you basically can deploy it anywhere. I cannot think about even edge devices which will not have this amount of memory in them. And as you can see, like the task was to determine different kinds of particles, so whether they're twisted right or left. So yeah, so as you can see, particles that are twisted right are colored as yellow, as green ones, and the particles that are twisted left, they are colored in different color. And what we leverage here, we leveraged the power of synthetic data. So for training this neural network, we used only around like 30 original images, which is quite real to obtain. Yeah. And from that, we generated 10,000 very diverse images. Wow. And in fact, all the images that you can see here, they are all synthetic. So all of them are not real images, but images that were generated. And as you can see here, they're very diverse. So they're very different images.
Is this just doing kind of inference at the edge, or and then retraining is in a separate kind of workflow?
Yes. So here we are talking only about inference on the edge. So training on the edge, or sort of like federated training, is a different beast, which is very complex in itself. So right now, what I'm working on is just inference on the edge. So here we have this model, and it performs very, very good. So, and what we found, it is also generalizable. So when you show it different particles with more or less same like characteristics, but they're obviously different, it still can perform quite well on them. And it speaks to the power of smaller neural networks and their abilities to perform very well in some narrowed down scopes. So here we have narrowed the scope to one type of analysis of like this specific use case. And with that, we were able to train very small neural network to perform like greatly on that. And I think that this is not an isolated case. So we can leverage basically the same thing for other cases, for other industries. And
yeah, I can certainly see this being applied for, say, images with quality checks on part checks in that same way. Like a small subset of images for those quality checks, and then using a model similar.
And in terms of, do you batch kind of data back out from the model? Like, let's say that I wanted to monitor over time or look at outputs over time. Like, how, from an architectural perspective, what have you seen work in terms of patterns on kind of the output data getting back into some of the other systems, even some of the metadata on performance and whatnot?
Yeah, so here in this specific case, in browser deployment, it maybe in cases with which I'm working, it doesn't make sense to like batch anything, because everything is performed in sort of like interactive way. Like you select image or you make image and you get the result immediately right away. But deployment in browser is just one, is just one of the cases of edge deployment, and it is not, maybe not the most like prevalent. Other cases which are more like widely adopted are less visible, sort of like you cannot see them, you cannot like grasp them with your eyes. They are like hidden deep in the like factories, machineries, or some IoT devices scattered like in the wild. And there you definitely can and should leverage batch processing, because it will be faster and more performant. And one great thing about deploying models on the edge, it can really enable something that you cannot, like you couldn't do before. For example, if you deploy some sensors in the wild, like somewhere in areas far away, you basically do not have access to these sensors for the majority of part of the year, for example. And you can access them like once or twice a year. And you cannot get all the raw data from these sensors. But if you deploy like some very well-trained and small models on this device, which can process over time and accumulate only like metadata and like processed results, you can actually extract these for your purposes, for analysis, for understanding of like what's going on with the sensor, like what maybe something is wrong with the sensor or the area around like the thing that it is monitoring. So edge AI enables in itself, it enables a lot of new possibilities which are not that available otherwise.
I think that's fantastic. Thank you so much for showing this, Alex. And just for folks who are curious, Alex also contributed to our ebook. So I just dropped a link to the ebook in the chat for everyone to go and check out. I know we just have a few minutes left, Alex, and we've talked a ton about the pros of edge deployment as well. I also want to bring up kind of common pain points or common issues that you see as considerations in terms of deploying to the edge. What are some of the cons, or what are some of the gotchas that you've seen in your own work related to it?
Yeah, so the most obvious con is that in edge devices, you are limited in one way or another. So you are either limited in computational power, or in terms of memory available, or in terms of some restrictions, like corporate restrictions, other technical restrictions. So you will be limited in one way or another. And you need to understand these limitations from day one. So even before you started implementing anything. So because of that, I would recommend anyone who is considering edge deployments for their models, no matter like machine learning or deep learning. So start with understanding limitations. So what will be trade-offs of that? So either you will not be able to use very like large models, or your inference will be slower than you are used to when running in like high performance clouds. So you need to understand these limitations and design around them, because otherwise in more like greenfield cases or greenfield scenarios, you are free to like do a lot of stuff. Like you are not limited in computation, in like basically in anything, like everything is available in abundance. Yeah, but in case of edge deployments, you will be limited in something or in many things at once, and you need to understand it first. Otherwise you can like implement something, be very excited that I will deploy it like tomorrow everywhere, and then you will run into very obvious like limitations, which will like crash and destroy all your work for like last couple of months. So yeah.
Yeah, and I'll add one thing. I know we don't have any time to dive into this, but I think there's probably other security considerations in terms of like keeping the model secure, the data secure when it is deployed.
This one thing that I do not have enough information about it, but obviously when you're deploying to the edge, you are deploying your models to your client. And if your models have some advanced IP in them,
So you want to protect this IP somehow. And there are ways to apply some DRM or some encryption on the models, but these are very tricky things to pull out. And at the moment, I do not have enough information even to like dive into if we even had time for that. So.
Certainly demands another webinar, though. Thank you, Alex, for your time today. You can check out Alex's contributions to our ebook on getalignai.com. I dropped a link to it in the chat. You can also get to know us at getalignai.com as well. Alex, if people would like to reach out to you to learn more about the project you're working on or Beehive AI, how can they get in contact with you?
They can contact me on LinkedIn or in Twitter. So I'm quite active and monitor both of these networks.
Wonderful. Thank you for your time, and everyone who attended today. Thank you so much for joining. We will be posting this on our YouTube as well. Alex, have a great rest of your afternoon. Thanks again for joining.
You too. Thank you very much.
Thank you.
Have a good
Bye.
day.
See you, everybody.